Now let us talk about structural dependence. Structural dependence means that access to a file is dependent on its own structure. This means that all file system programs are modified to conform to a new file structure. On the other hand, we say that we have structural independence if the file structure is changed without affecting the application's ability to access the data. The next concept is data dependence. We say that we have data dependence if data access changes when data storage characteristics change as well. On the other hand, we say that we have data independence if the data storage characteristics are changed without affecting the program's ability to access the data, and the practical significance of data dependence is the difference between the logical and physical format. Next is data redundancy. Data redundancy occurs when you are unnecessarily storing the same data at different places. In this case, you are generating islands of information that are scattered in numerous data locations. This also increases the probability of having different versions of the same data. Possible results of uncontrolled data redundancy are the following: poor data security, data inconsistency, data entry errors, and data integrity problems. And lastly is data anomalies. Data anomalies develop when not all the required changes in the redundant data are made successfully. In this case, we have the following types of data anomalies. We may have update anomalies, which happens when you update a record in one place but did not update the same record in another place. Insertion anomalies, which may occur when you are inserting a new data in one place or one data location but not doing so in another one. And lastly is deletion anomalies, wherein you are deleting some data that you are not deleting in other data locations. Now, everything that we have discussed in the previous slides, they are going to be addressed when we use a database management system. If you can recall, in the file system, different departments are housing their own data. This can be problematic, especially if you are going to communicate with each other or share data across different departments. So, if we have a database management system, all logically related data stored in a single logical data repository. They are physically distributed among multiple data storage facilities, and it eliminates most of file systems' data inconsistency, data anomaly, data dependence, and structural dependence problems. Now, in the current generation DBMS software, they are also storing data structures, the relationships between structures and access paths, and defines, stores, and manages all access paths and components. In this diagram, we can see a typical database system environment. We can see that we may have a system administrator that supervises our database administrator. Now, the database administrator is the one managing everything that when it comes to our database. They are also writing and enforcing the procedures and standards that needs to be followed by the end users and the analyst programmers. Now, the application programs that are in-house or are accessing our database are connecting to the DBMS utilities, and of course, our database should be designed by a database designer. When we talk about a database system environment, they are an organization of components that define and regulate the collection, storage, management, and use of data within a database environment. And these include data, procedures, software, hardware, and even people who are handling all of these things. Now, let us talk a little bit about the different functions of a database management system. First, they are able to transform our data and present our data into a format that conform our logical expectations. Also, they can manage the security of our data by enforcing the user security in data privacy. We also have data dictionary management, wherein a data dictionary is, you can think of it as where we store the definitions of our data elements and their corresponding relationships. We also have data storage management that includes performance tuning to ensure that we have efficient performance in our database. We are also allowed multi-user access control We have sophisticated algorithms in place to ensure that multiple users can access that database concurrently without compromising its integrity. We're going to talk about this in more detail later on. We also have backup and recovery management, which enables recovery of the database after a failure. We also have data integrity management, which minimizes the redundancy and maximizes the consistency of our data. We also have database access languages and application programming interfaces. In this case, the language that we're using in accessing our data is a query language, which lets the user specify what must be done without having to specify how. And in our case, structured query language, which is the de facto query language in data access standard supported by the majority of DBMS vendors. And lastly, we have database communication interfaces, which gives us accept and user requests via multiple different network environments. Of course, in everything, there are two sides of the coin. We have already seen what are the advantages of having a database management system, but it also has some disadvantages. First, we have increased costs. Of course, it's going to cost a lot of money for you to integrate or implement a database management system. Next is management complexity. Since you are going to integrate it enterprise-wide, you're going to employ different departments to share the same data. It is going to have a toll on the complexity of the management. Next is maintaining the currency. Since DBMS is a system or software that you are using or getting from a vendor, it is important that you stay up to date with the latest version of your DBMS. Next is vendor dependence. Since you are not having your database management system in-house, you are going to be dependent on what the vendor is telling you on what to do on your database management system. And lastly, frequent upgrade or replacement cycles. As we all know, the hardware, for example, it needs to have some upgrade after some time. And so it all boils down to having the vendor do the upgrade for us, thus the disadvantages that are listed in here. And lastly, if you are looking forward to have a database professional career, these are the different career opportunities awaiting you. First is database developer, wherein you are able to create and maintain database-based applications. Database designer, wherein you are in charge of designing and maintaining the databases. Database administrator, you are in charge of managing and maintaining the DBMS and the databases. Database analyst, wherein you are developing databases for decision support reporting. Database architect, we are designing and implementing the database environments, may it be in the conceptual, logical, and physical layer. Database consultant, if you would like to help companies leverage database technologies to improve business processes and achieve specific goals. Database security officer, if you would like to implement security policies for data administration. Cloud Computing Data Architect, if you would like to design and implement the infrastructure for next-generation cloud database systems. And Data Scientist, if you would like to analyze large amounts of varied data to generate insights, relationships, and predictable behaviors. In this chapter, we are able to differentiate what data and information are, define what a database is, its various types, and its value in decision making. We have also highlighted the importance of database design. We have also discussed how our modern database system evolved from file systems. We have also tackled the flaws in the file system data management, described the main functions of a database management system, and also discussed the possible career opportunities awaiting for you as a database professional.